case one, keratoconus. This case has, as you can see, a very large inferior cone. And the question is will a small aperture IOL help you on this case or not? We have the ability with the iTrace software to show the cornea contribution to the vision separate from the internal contribution of the vision. So with the cornea side, you want to understand, will the small aperture essentially normalize the cornea? And we can do that very easily on the iTrace device. There's a decrease zone size button here on the far left. You can see the scan size or the effective optical zone that was scanned was 5 millimeters. But we have the ability to shrink the zone size down to 1.5 millimeters, illustrating how by reducing the aperture, you can clean up the cornea very nicely. And there's at 1.5. And it's essentially normalizing the cornea because all we are really concerned about is the center that counts. Let's go to a couple other screens here to illustrate the effect of the small aperture. The Chang analysis is an excellent screen to look at. Okay, here's all the higher order aberrations isolated here in a Zernike form. And it's just looking at HOA contribution of each one of those higher order aberrations. So once again, as we decrease zone size on the cornea, bottom left, you can see that the higher order aberrations essentially go down to 0 on this cornea. And so we've normalized the cornea by just shrinking down the aperture and filtering out all the low quality aberrated light represented by the cone. Case number 2, post-LASIK. Let's do the same thing we did with the keratoconus patient, where we use this decreased zone size to decrease the effective optical zone from 3.6 millimeters down to 1.5. And you can see very quickly on this post-LASIK account that we normalize the cornea by shrinking this aperture down, and we get a very nice clean E. So if you were to consider the small aperture for this particular patient, you would have a very good result. Let's go to the Chang analysis, where you can pick up all the higher order aberrations here that are contributing to that blurriness. Once again, as we shrink down the aperture, those HOAs go down effectively to 0. Case 3, Salzmann nodule. As you can see from the axial map down below, this patient has a Salzmann's nodule. That's creating quite a bit of ghosting and double vision. Once again, we'll decrease zone size to see if the small aperture would have a positive effect on this cornea. And it does, in fact, clean up the E nicely. Let's go to the Chang analysis, look at some of the higher order aberrations represented by the Salzmann's nodule. And as we shrink down the zone size, we essentially eliminate the noise, if you will, or the aberrations caused by that nodule. And so the small aperture might be a good choice for this particular patient. So if you have any more questions, feel free to reach out to myself or Alan Peck, listed on the email. We're happy to set up a virtual call and go over these cases and other cases in more detail, depending on your need. Thank you for your time.